So it turns out there's no such thing as like dividing two matrices. However, if we wanted to continue talking about, like identity, like 5 times 1 is itself, A times the identity matrix is itself, right? Now, when we're talking about numbers, if I have the number 5, what can I multiply that with in order to get 1? 1 over 5. So, guess what? So that's equal to 1, right? So guess what 1 over 5 is called? It's the multiplicative inverse of 5. Okay? So in the world of matrices, if I wanted to multiply a matrix by something and get sorry, this is supposed to be equal to 1. If I wanted to multiply a matrix by another matrix and get the identity matrix back, right? That's like multiplying by something to get a 1. Well, what can I multiply a matrix with to get the matrix equivalent of 1? Well, not 1 over. There is no such thing as 1 over, but it is the inverse. It's the inverse of the matrix. A inverse. Okay? So, for that, we need to talk about how to find an inverse. Okay? All right. We're going to start by square matrices. So basically what I want to call your attention to is if you have a matrix times its inverse, A times A inverse, or A inverse times A, in both cases you get the identity matrix. All right? So, take a look here. It says verify that A and B are inverse matrices. Okay. When you see the word verify, you have to do it using this process. You have to check if AB equals I and BA equals I. Okay, so let's see this. So it says to verify. So what I'm going to do is AB. 5, 6, 4, 5. 5, negative 6, negative 4, 5. This is going to give me a 2 by 2, right? Okay. All right, so row 1, column 1, what am I going to get? 25 minus 24, 1. Right? Now, row 1, column 2, negative 30, positive 30, 0. Right? So look, negative 30, positive 30, 0. Okay, now, row 2, column 1. Row 2, column 1. I get 20, negative 20, that's 0. Row 2, column 2, negative 24, positive 25, I get 1. Hey, what matrix is that? That's an identity matrix. Now, let's do BA. We know that matrix multiplication is not commutative, right? So let's do BA. I'm going to get 5, negative 6, 4, 5. 5, 6. No, negative 4. Okay. All right. Row 1, column 1, 25 minus 24, 1.
Where are you getting the minus?
So, 25 minus 24, negative 6 and 4.
Oh, sorry, let me go one up.
Yeah. Okay. Row 1, column 2. 30 minus 30, 0. Well, on the bottom, I get 0. And then I get 1. Identity matrix. So what happened? We knew that matrix multiplication was not commutative. AB and BA shouldn't have given us the same thing. How is it that they did give us the same thing? Well, it's because A and B are inverses. And so when I do AB and BA, it's not that I get the same thing, it's that both times I get the identity matrix, right? It's not the same random matrix, it's the identity. So, since I got identity for both of them, I say A and B are inverses. Okay, question?
Can't you just tell by the numbers?
Sometimes you can, sometimes you can't. But if it says verify, you have to show that work, right? Okay. Okay, so now.
Wait, so there's another matrix that would have given an identity for one, but not for the other?
Yeah, that could happen. Yeah, then there wouldn't be inverses, correct. It's exactly what it is. Okay, so determinant and inverse. All right, so how do we, okay, so now we know what it looks like if two things are inverses. But how do we find an inverse matrix, right? And, okay, so we're going to do a 2 by 2, right? Okay, so here's what we're going to do. First, matrices have a quantity called the determinant, all right? The determinant is a number unique to each matrix, and then later on when you do applications, you'll see like where it comes in handy. But let's first figure out how to find the determinant. So I'm going to do this first, the determinant. So if you have a matrix A, the determinant of A, this is how the notation looks. Or you could do like the bars A, that means determinant. Or you can put the matrix in the bars, and it also means determinant of the matrix. How do you find the determinant? You multiply the main diagonal minus the other diagonal. Okay? Now, once you have your determinant, you can find the inverse of the matrix. So here's how you find inverse. A inverse is 1 over determinant of A times. Check out what happens. So look at the matrix. This is the matrix that we're going to find the determinant of. A, B, C, D. Okay? In order to find the inverse, you change places for A and D. They just change seats. B and C stay where they are, but they become negative.
Do you always do the left?
Yeah.
The right?
You just do the whole thing. Like it doesn't matter which one you do first.
No, like
Oh yes.
The A, B,
Yeah.
and the A, B.
Always the main diagonal first. Yeah. Yeah. Okay. So let's do this one. Okay, so first let's find determinant. It's this. So 40 minus 40, 0. So now, A inverse is, remember we said it's 1 over the determinant times, blah, blah, blah. What's the determinant now? 0. And can we do 1 over 0? No. So, what does that mean? When the determinant is 0, There is no inverse. There is a word for that if you're on Jeopardy ever. It's called a singular matrix. A singular matrix has no inverse. Okay, now let's do one that does have an inverse. This one. Okay, first let's find determinant of A. It's that diagonal, negative 12, minus the other diagonal, negative 16. And that's 4. Okay. A inverse is 1 over 4 times. Change the places of the main diagonal. So 6 up here, negative 2 up here. And the other ones, they just change sign. So negative 4 on top, positive 4 on the bottom. I know it looked like those changed places too, but they just changed sign. Okay, now it's scalar multiplication. So you just distribute, and we get 6 over 4, which is 3 over 2, negative 1, 1, negative half, and that is A inverse.
Wait, wouldn't the negatives for the 2 4s be in opposite spots?
No, no. To do inverse, you switch the sign of the second diagonal. That's how it works for a 2 by 2. Okay, the process for a 3 by 3 is different. Okay, now look. I have had, okay, this is the OG way of finding determinants of a 3 by 3 in that box up there. Okay? You know, for some it's a pain. I rather enjoy it. Okay? But there is a shortcut. There's a shortcut, and that's what we're going to do. We're going to do the shortcut. I've given the steps here, 1, 2, 3, 4. But listen, it's super easy. So look at what you do. You see this matrix, ABC, all the way to here? You reproduce the first 2 columns here. Just clone them. Just copy them down. Now, you draw arrows like this, right? So, you find the product of the numbers on arrow 1, 2, 3, and you add them to each other. And then you find the products of arrow 4, 5, 6, and these just get subtracted. Okay? And for all 3 by 3s. Okay, so hey, why don't we do one? It says to find the determinant, then the inverse if it exists. We're just going to do determinant first. We're going to focus on determinant first, then we'll deal with inverse. So, first, reproduce the first 2 columns. Now, get the main diagonals. So, get the first diagonals here. So, first off, I have determinant of A equal to. Okay, the first diagonal, when I multiply everything on that diagonal, I get negative 15, right? Plus, second diagonal, 1 times 4 times 1 is 4. Plus, 0 times anything. We love it when we get zeros because that's just 0. Now I'm going to do the other diagonal. 1, 2, 3. Those blue ones are going to be subtracted. So here's what I, Miss Malikian, do. Before I even go to get the product, I put a minus, and then I go to my matrix. Because when I'm flustered, I will forget that minus, right? So minus 0. Minus, go to the diagonal. 3 times 4 is 12, times 2 is 24. Minus, go to the diagonal. negative 10. Then we add all this, and we get negative 25. Okay? You can write it that way. You can say determinant of A is negative 25. Cool?
What
Okay.
exactly is a determinant?
Okay. In your calculator, here's what you're going to do. You're going to go to menu. Look at number 7. Matrix and vector. And yes, we do want to create a matrix. Right? So create a zero matrix. I'm sorry, not a zero, a matrix. Number of rows, we're going to do A that we were just doing. So 3 rows, 3 columns, press OK. Oh, look at that, it's a matrix. Okay, put in matrix A that we were just working with. 3, now look, use the buttons here. If you press tab, it goes along the horizontal rows, right? So 3, tab 1, tab, what is it, 0, negative 2, ooh, negative 2, negative 1, 4.
Can you show us how you made that matrix again?
I know how to get. I'm not the
I'm
right.
gonna get the
not the
same
rows, but then
exact
it
way
like
when I
keeps
press
on
enter.
like just going up and stuff.
Use the,
I got the
oh,
same
use the
exact
mouse,
thing.
the mouse pad to go to the next.
Oh, I see.
Yeah, because it
Got it?
Yeah.
That's our matrix, right?
Yeah. Did you get it?
Now, everybody have a matrix? Oh my.
People at home watching are probably doing great.
Now we're going to go to menu. We're going to go back to matrix. But now, we want number 3 for determinant. Determinant. Okay, now it says determinant of what?
Control A.
If you've already selected, if you've already done this and pressed enter, you can do control answer. And look at that, the determinant right there, right there. Huh? That's actually very, very cool.
What you did.
So
all that chaos.
now, it turns out manually finding the inverse of a 3x3 matrix is a pain in the neck. Because what you have to do is you have to get a 3x3 matrix, and then you have to get another 3x3 matrix next to it, and you have to put one in row echelon form while the other one transforms magically into the... It's like a pain in the neck. But we're going to do it with our calculators. So,
You're not gonna let us do it on test.
no, I will. So here's what we're going to do. Okay, take your mouse, take your computer or calculator, bring your cursor here. You can hover and highlight this, right? Can you highlight this?
Yeah.
Click and drag and you can highlight. Now you can do Control C. Guess what that does? Guess what Control C does?
Copy.
It copies. So let's go down here now. Hover, bring your cursor back down here. New line. Okay? Control C, like Word.
Control V.
Yes.
Okay, we're going to go to menu. Oh, no, we're not going to go to menu. Sorry. We're just going to do Control V. Bring the matrix back. I'll show you later another way to do it. No. Yep.
And just scroll up.
Yeah, I'll show you that later on. I wanted to show you Control C, Control V also. Okay, now look. What's inverse? Inverse is to the power of -1. That's the inverse of this matrix.
Oh my god. Not a fan.
Oh.
Wait, so but we said work.
Nope, no work. No work. No work. So, the inverse is 13 over 25. Yep. You see where the determinant, the 1 over the 25, you see the 1 over 25 for the determinant, right? Negative 14 over 25, negative 3 over 5, 12 over 25, and so on. So now, here's the important part. Let's do a couple more things. Okay, so much to say. So, I am going to expect that you know how to find manually the determinant of a 2 by 2, the inverse of a 2 by 2, and the determinant of a 3 by 3. You are also going to be expected to be able to use your calculator to find the determinant of a 3 by 3, the inverse of a 3 by 3. Of these, if we were to do a Venn diagram, the only thing that you are not gonna, you cannot do by hand, you will not learn how to do by hand, is this. This you are only going to be able to do with the calculator, right? So on the test, on the homework, on the whatever, final, when I ask you for the inverse of a 3 by 3, it's with the calculator only. So you have to know how to use the calculator to find it. Am I making sense? Okay. Now, let's go back to the calculator. I'm going to show you a couple of other things. So suppose you did want this matrix, right? You did want that matrix. So what you can do, okay, so now we're here, right? What you can do is you can press the up arrow button, up, 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 until you find the matrix that you want. And when you press enter, that brings it down here for you in editable form. So you can do whatever you want with it, right? So, for example, let's do this. Menu, matrix, determinant, right? Now, go up, 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 press enter, and look, it puts it into the determinant for you. All right? You got to be savvy with this calculator, okay? Now, another one. Let's do another one. Let's go matrix, no, menu, matrix. No. I want to find the determinant of a matrix. Determinant of. Now I'm going to create the matrix right here. Menu, matrix, create. I want to do a 2 by 2. So why don't we do 1, 2, 3, -4. You see that? Right? Yes? Okay. Isn't that cool?
Yeah.
Okay. And then, you could experiment and see what some of these things are like. What's a transpose? Look, I wonder what row echelon form does. Go and experiment, okay? So the transpose of a matrix... Oh, sorry. I have to get a matrix first. That's actually funny. There are lots of math jokes with the transpose of a matrix. So let's...
Just to clarify, so in order to get the determinant of a 2 by 2, you do the cross thing, and then to find the...
Wait, hang on. Hey guys, look what transpose does. What did it do? What did it do?
It gave you the...
Gave you the 0.
The inverse before
No,
you...
not the inverse. What did it do?
It put it to the next step of row echelon form.
I think I'm going to stop the recording here, but the homework is